So before when we went backwards, we only had nice integer numbers, right? 2, 1/2, 3, -5. Now, with i's and square roots, think about the answers you've been getting from your polynomials. Have you ever just gotten square root of 6 as a root? Just a positive square root of 6? Or just a positive 3i? What was always in front of those roots? A plus or minus. So when you have i's and square roots, they always come in what we call conjugate pairs. So when you have roots with i's and square roots, you have to make sure that the conjugate pair is also there. So if I have positive root 6, I have to add a negative root 6. If I have positive 3i, I need to add in a negative 3i. So originally looking at it, it looked like we only had 2 roots. We actually have 4 roots. We have the plus or minus 3i and the plus or minus square root 6. You have all of your roots, right? You found, oh, I have all of my pairs. I included the conjugate pair of it. You then can set up your factors. And when you're dealing with more than just nice integer rational roots, when you have irrational roots and imaginary roots, I tell my students always set up your factors with the subtraction operation. And that'll become more relevant in the next example. So what I mean by that is always set up with an x minus. So my first root is a negative 3i. I'm going to go x minus negative 3i. X minus a positive 3i. X minus a square root of 6. X minus a negative square root of 6. If you always use subtraction and then simplify, because you know what's a double negative equal. Double negative is a positive, adding opposite. So this becomes adding, and this becomes adding, okay? So just always use subtraction, and then go through and simplify each factor, and then you won't get those wrong. Those should always be right, okay? So that would be maybe the first thing to put in your notes. Always use subtraction when setting up your factors, something like that. I would put something like that in your always use subtraction when setting up your factors, okay? Then the second big thing is going to be always multiply your conjugate pairs together first. That would be the other thing. Always multiply your conjugates together first. Why? Because if I multiply these two together with a FOIL, my i's will cancel out. And then when I multiply these two together with FOIL, the square roots will cancel out. You cannot have a polynomial with i's and square roots in it. If you have a polynomial with an I or a square root in it, it's not a polynomial. Okay? So you always want to multiply the conjugate pairs together to get rid of the i's and square roots. Okay? And since I have a binomial with binomial, I can FOIL. So x times x times negative 3i, 3i times x, and then 3i times negative 3i would be negative 9i squared. Right? And see what happens? My I terms here, negative 3, positive 3, those cancel out. That's 0. Negative 3 plus 3 is 0. And what do I know about I squared? It's negative 1. So really, this is negative 9 times a negative 1, which would be positive 9. So multiplying these two together, I get this. Right? And if you think about it, I've been challenging you a lot to do this in your head. If you ended up this as a quadratic and I said solve this, what would you do? I would subtract 9 and square root both sides, and what would my roots be? Plus or minus 3i. Okay, so that works. Then you'd want to FOIL these two together. So x squared plus square root 6x minus square root 6x And then what's square root of 6 times square root of 6? Square root of 36, which is 6. Right? Right? These cancel out. So I just get x squared minus 6. Am I done?
No.
One more multiplication. I need to multiply these two together. Right? Because remember, if I have 4 roots, I need a 4th degree polynomial. So FOIL these two, x to the 4th minus 6x squared plus 9x squared minus 54. Combine like terms. Right? And I have my 4th degree polynomial with my 4 roots.
Whoa, 54?
Example, we saw roots like this when we used quadratic formula. When we used quadratic formula, we ended up with roots like this. But you need to think a little bit. If 1 minus square root of 5 is a root, which one am I missing?
Plus.
1 plus square root 5. And if 2 plus I is a root, what am I missing? 2 minus I. Very good. So really, I have 4 roots. So when I multiply and get a polynomial, what degree polynomial should that be? A 4th degree, a quartic, a 4th degree polynomial. Okay. Now, first step I said is when you set up your factors, we're going to always use what operation? Subtraction. Right, subtraction. Okay. So x minus 2 minus I, x minus 2 plus I, x minus 1 minus root 5, x minus 1 plus root 5. Okay? And this is why I said always use subtraction, because when you have kind of crazy looking roots like this, it gets a little bit confusing to do the opposite. Okay? Now, we don't want parentheses within parentheses, so we do need to distribute that subtraction to get rid of the parentheses. Okay? So I'm going to take this negative and go to both terms. So this is going to become x minus 2 plus I, because double negative is positive, remember. X minus 2 minus I, x minus 1 plus root 5, x minus 1 minus root 5. Okay. See how I just simplified? All I did was distribute the subtraction to both terms to get rid of those parentheses. This will be an example where I cannot use FOIL because I do not have a binomial. I have trinomials. These all have 3 terms. So I'm going to use the table. I'm going to use the table to multiply these two together. And then I'm going to use a table to multiply those two together. And then once I have those 2 products, I'm going to use a 3rd table to bring those together to get my final answer. Okay? So not hard, but this you can kind of see this is going to take a little bit of time. Okay. I'm going to multiply these together. You let one of them be your columns, and it doesn't matter which one, right? If you do the opposite of me, that's fine. One of them be your rows. Right? And this is where you just multiply, right? X times x would be x squared. X times negative 2 is negative 2x. X times I is ix. And then you do the second one. Negative 2 and x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times I is negative 2i. Negative I times x is negative ix. Negative I times negative 2 is positive 2i. And then negative I squared.
So stupid.
But if you look in your table, you should notice all of your I terms are going to cancel out. That'll always happen because you cannot have a polynomial with i's. So if you look at your table, negative ix, positive ix, those cancel out. Positive 2i, negative 2i, those cancel out. And what do we know about I squared? It's negative 1. So this is really negative times negative 1, which is positive 1. Combine like terms. and I get x squared minus 4x plus 5. Now we need to do that again for my other conjugates. So over here, let that one be my columns. That one can be my rows. Right? And again, remember, it doesn't matter if you have row, column, it doesn't matter, as long as you're multiplying them together. So then I'd x squared, negative x, square root 5x, negative x, positive 1, negative root 5, negative root 5x, positive root 5, and negative 5. How do I get negative 5? Because square root of 5 times square root of 5 is the square root of 25, which is 5. And again, see how your square roots are all going to cancel out? Negative square root 5x, positive square root 5x. Those are gone. Positive root 5, negative root 5. Those are gone. So what do I have? I have x squared minus 2x minus 4. Combine x's, combine constants. Okay. So then, right, I still need to multiply these two together. So one more table to bring them together. Right, I got to bring these two together in a table. So x squared minus 2x minus 4. X squared minus 4x plus 5. Right? And you should look at your first term here. This is where my x to the 4th degree is going to come. Because, right, 4 roots, I needed x to the 4th degree polynomial. There it is. Keep multiplying. This is going to become cubed. 4x squared. This is a cubed. Positive, because remember double negatives, positive. 16x. This would be 5x squared. Negative 10x. And then negative 20. And notice my like terms are lined up diagonally. So then my final answer, x to the 4th minus 6 x cubed. Add your squareds together. So 9x squared plus 6x minus 20. So there would be my answer. Okay. So it's a lot of multiplying. Multiply, multiply, multiply. All right, let's do a couple of homework problems. 27. If I have positive 2i, what root do I need to include? Negative 2i. Very good. If I have positive square root 2, what root do I need to include? Negative square root 2. Now, I challenge some of you to use your brain. If I have the roots, think about this. If I had the roots plus or minus 2i, what would have been my polynomial that I solved? What would I have solved to get plus or 4? I would have had x squared plus 4, right? Because if I solved this, I would have subtracted 4 and square rooted both sides. If I have plus or minus square root of 2, what would have been my polynomial? X squared minus 2, because I then would have added 2 and square rooted both sides. Okay? If you can do that in your head, that's great. Do that. If not, let me show you. That's okay if you can't. Okay? You always use minus, right? Right? And double negative means positive, right? So these get changed to positive. And then we always multiply the conjugate pairs together. So this is going to get multiplied together. First, outer, inner, I know about these terms? They cancel out. And what do I know about I squared? Negative 1, so this is really plus 4. See how right? We did that in our head earlier, but that's how we got it, if I wanted to do it mathematically. Multiply these two together, FOIL. Right? Square root of 2 times square root of 2, square root of 4, which is 2. Those cancel out, and I get x squared minus 2, right? Which we also got. If you just thought about it, right? We add 2 square root both sides. And then I'm not done. You have one more step. FOIL those two together. So first, outer, inner, and last, combine your x squareds. And there's my 4th degree polynomial with my 4 roots. So, again, if I have 3 plus I, what's my other root? 3 minus I, very good. If I have 1 minus root 3, and when I set up my factors, I always use what operation? Subtraction. So x minus, right, x minus 3 plus I, x minus, and x minus. Right? Get rid of the double parentheses by distributing the negative through, right? Distribute the negative through. Again, right? Get rid of your parentheses by distributing. Okay. Then the second thing I said was you always multiply your conjugate pairs together first. There are no binomials, so we need to use a table. And just like our second example, we're going to use a table 3 times. A table to multiply these two together, a table to multiply these two together, and then a third table to multiply those two products together. Okay? So here's my first one, x minus 3i, x minus 3 negative I, and then multiply. So I get x squared minus 3x, ix, negative 3x, positive 9, negative 3i, negative ix, positive 3i, negative I squared. And what you should see is that your negative ix, positive ix cancel out. Positive 3i, negative 3i cancel out. And what do I know about I squared?
Negative 1.
So this is plus 1. So I get this. Okay. So that's the first two multiplied. Now I need to multiply these two together. So x minus 1 square root 3, x negative 1 negative root 3, multiply x squared, and again what you should get is all of your square roots will cancel out. This is negative to positive, gone. Positive, negative, gone. So combine like terms, I get that. So then one more table, because I need to multiply this with this. So I need one more table set up, and that'll get me my answer, my polynomial. So I'll set that up in the middle here. X squared minus 2x minus 2, x squared minus 6x plus 10. Do some multiplying. Here's my 4th degree, right? Because I know 4 roots, I need a 4th degree polynomial. And then 6x cubed.
Does it matter if I did it like the other way around?
Nope. You can switch the row and column terms. And your like terms should all line up. Kind of a way to check yourself. They all kind of line up nicely. So then my answer, x to the 4th, here's my cubes. So I'd have negative 8x cubed. Here's all my x squareds. So plus 20x squared. Here's my x's, minus 8x, and minus 20. So that would be the simplest polynomial with those 4 roots.